Okay, guys, so the last part of chapter 8 will be acid deposition. And the 3 points here are that rain is naturally acidic, but we have something called acid rain, which is not the natural rain. And acid deposition is formed when oxides of nitrogen, sulfur dissolve in water to form these slightly common acids. Some are more common than others, like sulfuric acid here and nitric acid there. But we have less oxidized ones too, like nitrous and sulfurous acids. So, and the other part is sources of the oxides of sulfur and nitrogen. We should cover their effects in this. Okay, so going on to talk about rain. In nature, rain is acidic. Its pH is about 5.6. This is natural rain. It's acidic, but we do not call it acid rain. Okay, we have naturally acidic rain because in the atmosphere we have a lot of carbon dioxide, and when carbon dioxide mixes with water, it forms an acid called carbonic acid. This is the same acid that can be found in fizzy drinks. So when you open a bottle of Coke, for instance, you hear that fizz. That's because the equilibrium is shifting from this side going that way. So carbon dioxide is being produced and you may see some bubbles there. Okay, so rain is naturally acidic because of carbonic acid. It has carbonic acid in it naturally, but that is not acid rain. Okay, so when it is acid rain, it means that the pH is lower than that. So it's more acidic. It contains more acids except for carbonic acid. The contributors are the oxides of sulfur and nitrogen. So sulfur oxides and nitrogen oxides. They are more than one of each. And in chapter 3, we looked at oxides of period 3, and sulfur is one of those, sulfur oxide. We saw there was sulfur dioxide and there was sulfur trioxide. Okay, so these oxides, they are the primary pollutants. And then when that oxide is mixed with water, then it forms an acid, and that acid, that solution that is formed, the rain, becomes a secondary pollutant. We take the primary pollutant and we mix it with water to form the secondary pollutant. So here we have a definition of acid deposition. And there's two types. There's wet and then there's dry. Okay, let's have a look at some of the oxides that we're dealing with here. So for the sulfur oxides, we have equations for the formation of this. So this is the primary pollutant. Take the primary pollutant, you add it with water, you form the secondary pollutant, and this is the solution in the rain. Like this is what acid rain is. It's a solution of water from rain and sulfur dioxide. Okay, sometimes this sulfur dioxide can be further oxidized to form sulfur trioxide, and the sulfur trioxide with water forms sulfuric acid, which is a more caustic acid compared to sulfurous acid. So this is sulfurous, this is sulfuric. Okay, so this is more caustic, more acidic, more dangerous, if you may. Okay, so these two here are what we call secondary pollutants. This is a primary pollutant. Okay, we have then the example for nitrogen. We have nitrogen mixing with oxygen to form nitrogen monoxide. Nitrogen monoxide. Nitrogen monoxide itself can mix with oxygen to form nitrogen dioxide. Nitrogen dioxide. Okay, and then the nitrogen dioxide mixing with water will form nitric acid and nitrous acid. Okay, nitric acid is one of the common acids, and it comes from nitrate which is one of the polyatomic ions you need to know. So when it has the hydrogen, when it's protonated, this is nitric acid. So there is some impact on building materials. Some building materials are made of marble and limestone, and as we know, those are carbonates of calcium. And these carbonates of calcium are pretty insoluble in water. These dissolve very, very little in water. Okay? But if we have an acid, if we react an acid with these carbonates, we form something called calcium sulfate, which is more soluble in water. Here are some of the reactions, balanced equations here for calcium carbonate reacting with some of these reactants. So here we have calcium carbonate reacting with sulfur dioxide in the presence of oxygen to form calcium sulfate and carbon dioxide. Okay, so this results in destruction of the building material because, like we said here, calcium carbonate is insoluble in water, so it can be used as building material, but it now forms calcium sulfate, which is more soluble in water. And it also produces carbon dioxide, which adds to the acidity of rain, because carbon dioxide, if it mixes with water, it forms carbonic acid. Okay, this reaction here, you should be able to balance it yourself. So we have calcium carbonate and we have sulfuric acid. Okay, this undergoes a double displacement reaction where the cations switch places and the anions also. So we have a double displacement reaction. So here you should be able to figure out the products that are formed. Okay, give it a go. Same thing with the calcium carbonate and the nitric acid. So you can take a break, you can pause the video now and give it a go. Okay, I hope that you were able to find that here we form calcium sulfate plus we form H2CO3, which is carbonic acid. Okay, H2CO3. Okay, and then for the second one, we form calcium nitrate and carbonic acid. Okay, calcium is 2 plus and then nitrate is 1 minus. So this is supposed to be 2 minus for sulfate. This is 1 minus, so that's why we have the formula as it is. Carbonic acid at room temperature and pressure or higher dissociates into carbon dioxide and water. So if you had this situation happening like on a regular day, maybe let's say summer day, and the temperatures, let's say, are more than 25 degrees, then you just have calcium sulfate because the carbon dioxide and the carbonic acid would turn into carbon dioxide and water. And then if rain comes on a different day with calcium sulfate there, it will just dissolve and be washed away very, very easily. Okay, this is why a lot of marble statues or marble building materials, you find that they are getting etched as rain falls on them because the rain has become more acidic. Okay, some of the effect is not because of calcium of lime and marble or limestone and marble, which are calcium carbonate. Some of the effect is because some building materials are metallic, and we know that metals react with acids. We know that metals react with acids, and in this case we're again forming a sulfate. We form sulfates. So when we have when we have iron react with sulfur dioxide in the presence of oxygen, we form iron sulfate. Okay, this equation here is not balanced, so you can balance that. I hope when you balance the equation, you found that we have this. And then you can also have the ion or the metal react directly with the acid to form the sulfate and some hydrogen gas. Okay, metals react with acids to form hydrogen gas. So I'll let you guys work on 2 and 3 and send me a message to confirm that you've done this and you know what the answers are. Okay, there's also an impact that can happen on plant life, and this can cause slower growth and some injury and death on plants. There's some minerals in the soil that can be washed away because they've become more soluble. For instance, the iron is not one of them, but I'll just give you an example here. If iron is a solid here and it's in the soil, it's harder for that iron to be leached out. But if it is made into iron sulfate, which is more soluble in water, then it is easy for it to be washed away when rain comes. Okay, and some of these are really, really important. For instance, magnesium 2+, it forms the center of chlorophyll, the chelate that results in the greenness of plants, and that is very important in photosynthesis, which is the source, which is a way for almost all organisms to convert energy from the sun to energy that we can use. Also, these ions, some of these ions can be very dangerous or toxic for plant roots. And also, not just plants, even humans. If these ions, this previously unavailable and insoluble elements, now get dissolved and they reach water, whether you are using that water to bath or to swim or to eat or whatever, that can be dangerous for all life form. Another thing, acid rain can result in dead water bodies. And what does it mean, dead water bodies? It means that life cannot be sustained in that environment. For instance, below pH 4, fish cannot live. A lot of fish cannot survive. So if you have acidic water in a river, then the fish in there cannot survive. And if the fish do not survive, then other life forms that depend on the fish for their survival, then they also cannot survive, or they have to evolve or adapt. Something that may look like it's a good thing, but it's actually not, or it cannot be. It can sometimes be a very, very bad thing, is eutrophication. And that, if the bio people may tell you, that is when we have an overgrowth of the green stuff because the water is too fertile. If the water is very, very fertile, then the green stuff actually, but they are water plants, and also algae can bloom. And then when they bloom, they will be using a lot of oxygen for their survival, for their respiration, and that will mean that the water now does not have enough oxygen. Okay, and then things start to die. And I've said it's not just plants, it's not just the fish, also human life. In all the ways that plants and fish and whatever else has been affected, humans that use that or that rely on that can also be affected. But on top of that, some of these toxic ions that are released as a result of acid rain are actually very, very dangerous for humans, and they can result in a lot of health problems. Basically, a lot of what humans do result in acid deposition, and acid rain is a real problem, and it doesn't just affect the people who are responsible for making it. So it affects other communities that may not have anything to do with it directly. Okay, so because this is a global problem, of course, global leaders have come together to try and see what can be done in order to reduce the emission of these dangerous oxides. More commonly the oxides of nitrogen and sulfur. Okay, so there's different ways that can be done. Some ways they deal with the problem before, so they deal with the raw material before you combust it, before you burn it. Okay, so that at the end you do not produce some of these oxides, or you produce them at a low level, like you don't produce a lot of this oxide. Some of them you deal with after you've produced the oxide. Then how do you treat it so that it becomes less dangerous? Okay, but of course, as you can imagine, these methods, like doing these extra things, can cost more money, and a lot of companies do not like having to do this because it will affect their profit margins. Okay, so it is up to people and governments to have policies that prevent private companies from doing or using methods that are going to increase the amount of oxides of nitrogen and sulfur in the air. Okay, but there's always a pushback from the people who own the companies because they are usually more concerned about their money. Okay, so here an example of what we can do pre-combustion is the sulfur that is in the coal that later on becomes sulfur dioxide can be reacted with hydrogen to form hydrogen sulfide. And even though this is also a very bad guy, it can be used. It is a useful bad guy that can be collected and used in the production or the manufacture of sulfuric acid. And as you know, some of you have used sulfuric acid in the lab. It is a very popular and very useful acid when used in the lab properly. Very dangerous, but still very useful. In the post-combustion method, one way that can be employed is reacting the sulfur dioxide that has been formed. That's why it's post-combustion method. It can be reacted with calcium carbonate or calcium oxide, and this will result in the formation of calcium sulfate, which is then used for something else, like forming plasterboards. Okay, remember we said calcium sulfate is a little bit more soluble than calcium carbonate, so this can be formed as well. How about nitrogen? How can we deal with nitrogen oxides? So one of the ways that nitrogen is formed, or nitrogen oxide is formed, is in the combustion of fuel in the engine, in the automotive engine. Okay, so in this way, in this form, cars from a certain year have to have catalytic converters. And these catalytic converters, they convert a very, very, very toxic and noxious gas called nitrogen monoxide. And they convert nitrogen monoxide and carbon monoxide, both of which are very bad and can kill you very, very quickly. So these two combine to form carbon dioxide, which we know can form acid rain, can contribute to acid rain, but it's at a very benign level. Okay, so carbon dioxide compared to carbon monoxide is very, very friendly. Okay, so we form carbon dioxide and nitrogen, which is pretty inert. Okay, so we've turned two very noxious gases into two very, very friendly gases. Okay, and the catalysts used here are usually transition metals. Platinum or palladium are the popular ones that are used. Okay, and then another method is we can use collision theory here and factors affecting rate of reaction, or our knowledge of that. We know that at lower temperatures particles have a lower average kinetic energy, and therefore the rate of reaction will be slower because we're not having as many collisions as at high temperatures. So if we can reduce the temperature in the engine, then the formation of nitrogen monoxide gas will be lowered. And some of the other things are things that are not directly related to removing the oxides, but rather preventing them from being formed. So things like using public transport more. So if we have more public transport use, then there'll be less private car use, and there'll be less emission of these troublesome oxides. Okay, using renewable sources of energy instead of using petroleum products, because when those burn, then we form side products that are not friendly. And making sure that you use efficient energy transfer systems. Energy is always transferred from one form to another, and during that transfer, like if I have fuel that has potential chemical energy, and then if I want that to move my car, then there has to be some combustion, and then energy is going to be transferred from the fuel to something else. That will result in energy production, and that energy may be more available for my use. So if we make sure that when this energy is transferred from one form to another, that it's very efficient, like meaning that there's no, for instance, heat loss to the surrounding, or no energy loss to the surrounding, like energy that just gets wasted because it wasn't efficiently converted. So if we have more efficient energy transfer systems, I'll give you an example. In your house, you can use LED lights instead of the filament ones, because the filament ones, they are there to give you light, but there's also heat that is produced, and that heat most of the time is just wasted because you only need light from your bulb. You don't need heat, so that heat is just wasted in the surrounding. So if you use LED mostly converted to light, not heat. Okay. And then one other thing that is being used, which controversial too, lime has been used to neutralize lakes and restore ecosystems. Okay. The thing about nature and ecosystems is that it's good to just let it be and let it do its thing naturally. When you try to fix one thing, something else may be affected negatively. So really using public transport so that we don't form the gases, that's one good thing. And then not burning those petroleum products that will give us these bad gases. And then also making sure that we use more efficient energy transfer systems. I think those are the best ones. But if there's a special lake somewhere, people have done this. People have used lime to neutralize some lakes and restore ecosystems.